Lab 14, solids in cigarette smoke. One of the most important contributors to indoor air pollution is cigarette smoke. Cigarette smoking is a widespread habit in our society, and it is likely that the social, political, aesthetic, and medical issues resulting from cigarette smoking have affected smokers and non-smokers alike. The addictive nature of nicotine and the impact of cigarette smoking on the health of smokers has been extensively studied for decades. In more recent years, the effect of so-called secondhand or side stream smoke inhaled by non-smokers has been evaluated and is now recognized as a significant issue for indoor air pollution. This laboratory investigation focuses on studying the smoke inhaled by smokers as well as side stream smoke. You will use a simple apparatus to simulate the smoking process and will collect, weigh, and observe the solid particles produced by burning a cigarette. This will allow you better insight into the quantity and nature of the solids in cigarette smoke. A burning cigarette produces harmless carbon dioxide and water, but many other substances are produced and they are not so harmless. Along with carbon dioxide, carbon monoxide is produced. This toxic gas competes with oxygen in the bloodstream, reducing the amount of oxygen that is available to cells. Blood concentrations of carboxyhemoglobin, where the oxygen carrier hemoglobin is bound to carbon monoxide instead of oxygen, are about 10 times higher in a smoker than that of a non-smoker. The nicotine in tobacco gets vaporized into a gas and is inhaled intact. Various minerals and carbon-based compounds are present as dust or ash. In total, cigarette smoke contains more than 4,000 different chemicals. Some of the chemicals in cigarette smoke are proven carcinogens or cancer-causing substances. Others have the ability to serve as promoters of cancer when carcinogens are also present. According to the American Lung Association, cigarette smoking is the primary cause of lung cancer in the United States. Emphysema is a chronic condition affecting 2 million Americans living in the United States. It is a condition resulting from the overinflation of structures in the lungs known as air sacs or alveoli, which occurs when the alveoli walls begin to break down. The result is a loss of elasticity in the lungs, as well as a decrease in the ability of the lungs to deliver oxygen to the bloodstream. In smokers, emphysema develops slowly after years of exposure to irritation of cigarette smoke. Emphysema and chronic bronchitis together are classified as chronic obstructive pulmonary disease, or COPD. Cigarette smoking is responsible for 83% of cases of COPD. Some of the compounds in cigarette smoke also affect non-smokers who inhale so-called secondhand smoke. This is the smoke emanating from the burning end of the cigarette. It can be inhaled by the smoker as well as nearby individuals, and is also referred to as side stream smoke. Inhalation of side stream smoke, sometimes called passive smoking. In 1993 report, the U.S. Environmental Protection Agency, or EPA, concluded that 3,000 lung cancer deaths annually are due to passive smoking by non-smokers. This map shows the share of people who smoke every day as of 2012. Interestingly, here is where we find the highest death rates from lung cancer. So I find it fascinating they don't have data for that. Morning, guys. Sorry we had to cancel class for today, but I still wanted to show you all this lab. It's not a live demo, but it's still a demo. I was particularly excited about this apparatus. This is like... Ozzy! Hey, come here! Come here! Come here! Hi! Come here! Come. All right, let's do this. You want to do it with me? Okay, you do it with me. So I wanted to make sure you guys got to see it and see it working, so I'm going to hope that the wind cooperates and it's not too windy. So an explanation of what we're doing today. we are going to do two trials, trial A and trial B. And what we're gonna do is we're gonna run a filtered cigarette up here and an unfiltered cigarette down here. And we're going to test both first-hand smoke, like what would be consumed by a smoker, him or herself, and second-hand smoke, which would be what's consumed by those of us who are in the presence of someone who is smoking. Now, when we were growing up, your parents and me, people our age, when we were growing up, there was, smoking was everywhere. So smoking is a lot less common these days, and it was actually really hard for me to find any unfiltered cigarettes. So I kind of had to doctor some. I took a filtered cigarette and I pulled the filter off the end. So I want to show you what we've got. For God's sakes. Because it's Ozzy! I want to show you what we have in the beakers first so you know what we're using. So, first things first. This contains our unfiltered cigarette, and I have pre-masked everything so that we can just get the mass after we've run the experiment. And so each of these beakers contains, like this one's an unfiltered cigarette, there's the mass on it, whoop. And then these are 2 filters, and it's the same for each one. All right, so for example, what? Hello. Oh, I can stay there. Okay, so for example, we're going to be running our unfiltered, that's you down here on the bottom, and our filtered on the top. What we're going to do is this funnel here is going to be our first-hand smoke. So we're going to place our unfiltered cigarette in here, and this is going to sit above it with a little bit of an air gap. All right, this is going to represent our second-hand smoker. So when we turn on the pump, it should start sucking air through that cigarette, causing it to burn down, just like it would if someone was inhaling it. So that smoke should come through the tube and down into this flask. But what we're going to do is put a filter right here between the tubing and the flask, right underneath the stopper. And that should catch all the solids, okay? We're going to do the same thing on this side. So this one here should catch the first-hand smoke. So it's one first-hand unfiltered, trial A and trial B, because we're going to run it twice. And this one over here should catch the second-hand smoke because it's going to come from up here. So I'm going to go ahead and set all that up before I turn it on, and I'll let you see it. Okay, so now we have both of our cigarettes set up. That one tipped over a little bit. Let's see if I can get it to stand up right in there. And now we're going to go ahead and put in all the filters. So, for example, this is one of the filters. We had to cut them. They're regular filter paper, but we had to cut them down. And this one is for our first-hand smoke, unfiltered, trial A. Okay, it's important that we leave a little air gap between the funnels because, as you know, combustion requires oxygen. So now what we're going to do is we're going to turn on the pump and cross our fingers and see if we can light these guys. And we're going to try to get them to burn all the way down to that little red line, and then we will break the seal between the pump and the cigarette itself, and then we will get masses for the filters with the solids collected on them. Okay, so here we go. And there they go. Here's a close-up. Ugh, they smell awful. Not only are they cigarettes, they're the cheapest cigarettes I could find, so they really do smell awful. So an issue we're experiencing is that the funnel is really narrow and the cigarette isn't getting a good enough seal, so I'm gonna do a little rigging. Okay, I just had to do some fairly significant re-engineering. I could not get the cigarettes to sit up straight, and there wasn't a good seal, so the vacuum suction wasn't doing its job of burning the cigarettes down. So what I did is I put a little modeling clay around the base of each cigarette. I actually got new cigarettes, I remasked everything, I have all that data. And I really squashed on those rubber stoppers to make sure they were in there nice and tight. So now we are going to try it again and see how we do. Fingers crossed, because it seems the wind has picked up, which is not what I was hoping for, but hey. Come on. You know, it would help if the torch lighter worked. There we go. All right, that looks positive. Let me get this down. There we go. All right, now I'll do the top. Well, that was very positive. It's a much better burn. All right, now we're gonna watch and see what we get. You can actually see it coming in. See it? That's the filtered cigarette at the top, first-hand smoke. And at the bottom, it's the unfiltered cigarette, first-hand smoke. That's what you're seeing. And then over here, these are the second-hand smoke. That one was the one I thought might be off, and it was just a little. There we go, that's better. This one just doesn't want to sit, so I'm going to hold it for a minute. You can see that smoke in the line. While it's running, I just want to show you, there's the unfiltered. Even with our filter paper, there is the unfiltered cigarette there on your right. And that is the first-hand smoke versus the second-hand smoke. That's pretty impressive. Here are the filters from trial A and trial B, sorted by first-hand filtered and unfiltered, second-hand filtered and unfiltered. And then our collection of filters at the bottom left-hand corner with our second hand to the left and our first hand to the right, and then a close-up of our first-hand filters. Here are our data tables. We can determine that our average solids per milligram of filtered first-hand smoke was 200.98 milligrams. And our average solids per milligram of filtered second-hand smoke was 209.37 milligrams. Our average solids per milligram of unfiltered were lower, which makes me think something was wrong in our measuring. Based on the data we did receive, our solids per milligram for secondhand smoke came in no lower than 66.67%. This experiment should definitely be run again to try and work out any wrinkles and see if we can get some more accurate results. Nevertheless, it was really interesting. Even if our results weren't super accurate, I think the moral of the story is clear.